Right now, as you look up at the night sky, you are not seeing the universe as it is. You are seeing it as it was. Every single star you have ever looked at, every galaxy, every glowing point of light you have ever pointed to and called beautiful, every constellation someone taught you as a child, every shooting star you made a wish on, all of it, every single one, is a ghost. Some of those stars no longer exist. They burned out thousands, millions, even billions of years ago, but their light is still traveling, still crossing the void, still reaching us, still fooling us into thinking they are there, alive and burning, steady in the dark. They are not there. They were there. There is a difference, and that difference is one of the most profound, most unsettling, most beautiful facts in all of science. And here is the part that should stop you cold. If that is true for starlight, if everything we see in the sky is a message from the past, not a window into the present, then what does it mean for us? What if, right now, somewhere across this unimaginably vast universe, a civilization is looking in our direction, and they are seeing the light that left Earth millions of years ago, before humans, before primates, before the first fish pulled itself out of the ocean onto dry land, before anything we would recognize as life the way we live it. To them, we do not exist yet. We are in their future, not their present. To them, we may never exist, because by the time our light gets there, they may be gone. And to us, right now, tonight, looking back at them, they may already be gone too. This is not science fiction. This is not a thought experiment invented to make you feel small. This is the actual, documented, confirmed, mathematically precise nature of physical reality. The universe operates on a delay measured not in seconds or hours or years, but in thousands and millions and billions of years. And once you truly understand it, truly feel it in your gut and not just acknowledge it in your head, you will never look at the night sky the same way again. Welcome. Today we are going deep. We are going into the most unsettling truth in all of science. The truth that the universe you think you see has already changed, already moved on, already died and been reborn in ways you cannot know. The universe you see is already dead, and so, in a very real and very specific sense, are we. Let's start with the single fact that everything else in this video rests on. Light has a speed limit. That sounds almost too simple, too basic to be important. But follow this thread carefully because it unravels everything. Light travels at approximately 186,000 miles per second. That is about 670 million miles per hour. It is the fastest anything in this universe can travel. Not just the fastest thing we have built, not just the fastest thing we can imagine, the fastest thing that physics, as we understand it, allows. Einstein showed us that nothing with mass can ever reach the speed of light, and nothing, not even massless particles, can exceed it. The speed of light is not just a record, it is a hard ceiling built into the structure of space-time itself. At that speed, you could circle the entire Earth 7.5 times in 1 second. You could travel from here to the moon in about 1.3 seconds. From here to the sun in about 8 minutes. It sounds instantaneous at human scales, and for most of human history, we assumed it was. When you light a candle, the room appears to illuminate instantly. There is no visible delay between the flame and the light reaching your eyes. But it is not instantaneous. It never was. It only seemed that way because for thousands of years, we were never looking at anything far enough away for the delay to matter. The first person to actually measure the speed of light was a Danish astronomer named Ole Romer in 1676. He was observing the moons of Jupiter, specifically a moon called Io, which orbits Jupiter so quickly that Romer could use its eclipses like a very precise clock. But something strange kept happening. Io's eclipses were not arriving on schedule. When Earth was on the far side of its orbit from Jupiter, the eclipses came late. When Earth was closer to Jupiter, they came early. Romer figured out what was happening. Light takes time to cross the extra distance when Earth is farther away. The delay was not in Io's orbit, it was in the travel time of the light itself. He estimated the speed of light as roughly 133,000 miles per second. Not perfectly accurate by modern standards, but astonishingly close for someone working in 1676 with nothing but a telescope and a clock. And most importantly, he proved the fundamental point. Light is not instantaneous. It takes time. Now, let's scale this up into something you can feel. When you look at the moon tonight, you are not seeing the moon as it is right now. You are seeing the moon as it was 1.3 seconds ago. The light you are receiving left the moon 1.3 seconds before it hit your eye. When you look at the sun, you are seeing it as it was 8 minutes and 20 seconds ago. If the sun suddenly, catastrophically exploded right now at this exact moment, you would not know for over 8 minutes. The light from the explosion would still be in transit. You would sit here, unaware, for 8 minutes and 20 seconds before the sky changed. Now look further. The nearest star beyond our own sun is Proxima Centauri. It is 4.24 light-years away. That is the distance light travels in 4.24 years. The light you see from Proxima Centauri tonight left that star over 4 years ago. Whatever is happening there right now, at this moment, you will not know for more than 4 years. And Proxima Centauri is our closest neighbor, the closest star, the next-door house in a neighborhood that stretches for billions of light-years in every direction. The stars you see with the naked eye on a clear night are not 4 light-years away. Most of them are hundreds of light-years away. Some are thousands. You are looking at a sky full of messages that left their sources long before you were born, long before your parents were born, long before their parents were born. Betelgeuse, the famous red supergiant in Orion, is approximately 700 light-years from Earth. When you look at Betelgeuse, you are seeing it as it was around the year 1325. The 100 Years' War between England and France had not yet begun. The Black Death had not yet swept through Europe. Dante Alighieri had just finished writing the Divine Comedy a few years earlier. That is the Betelgeuse you are looking at tonight. And Betelgeuse is dying. Astronomers know it is a star in the final stages of its life, a red supergiant burning through its last reserves of fuel before a catastrophic collapse and explosion, a supernova so bright it will be visible in daylight from Earth. When will that happen? Scientists debate this. It could be anywhere from within the next 1,000 years to within the next 100,000. The uncertainty is enormous. But here is what keeps me awake at night. Because Betelgeuse is 700 light-years away, the explosion may have already happened. Right now, as you watch this video, Betelgeuse may be gone. It may have exploded centuries ago. The light and shockwave from that explosion may already be somewhere between Betelgeuse and Earth, moving toward us at 186,000 miles per second. We're not waiting for Betelgeuse to explode. We're waiting for the news to arrive. The event itself may be over. We just have not received the memo yet. That distinction between what has happened and what information about it has reached us is at the heart of everything we are going to explore today. I want you to do something. Next time you are outside at night, under a clear sky, away from city lights if you can manage it, I want you to look up and really think about what you are seeing. You are not looking at the universe as it is. You are looking at a mosaic of different pasts, light from hundreds of different distances, sent at hundreds of different times, arriving at your eyes simultaneously, creating the illusion of a single, unified, coherent present. But there is no present up there, not in any meaningful sense. The sky is a temporal collage, a patchwork of different eras, layered on top of each other. Let me take you on a tour. Look at Sirius, the brightest star in the night sky, blazing white and steady in the winter months. The light hitting your eyes from Sirius tonight left that star about 8.6 years ago. You are seeing Sirius as it was roughly 8.5 years in the past. Nothing dramatic there, but nothing current either. Look at Aldebaran, the bright orange-red star that marks the eye of Taurus the bull. That light is about 65 years old. You are seeing Aldebaran as it was around 1960, the height of the Cold War, the beginning of the space age. Yuri Gagarin had not yet orbited Earth when the light you are seeing tonight left that star. Look at Rigel, the brilliant blue-white star at Orion's foot. Rigel is about 860 light-years away. The light you see from Rigel tonight left that star around the year 1165. The Third Crusade had not yet happened. Genghis Khan had not yet been born. Saladin was a teenager. Look at Deneb, the bright star at the top of the Northern Cross. Deneb is so luminous, so blindingly powerful, that even at its enormous distance, it shines brightly in our sky. Astronomers still debate exactly how far away it is, somewhere between 1,400 and 2,600 light-years. Either way, the light reaching your eyes from Deneb tonight left somewhere between the collapse of the Roman Empire and the early Tang dynasty in China. The sky is not a photograph of the present, it is a museum. Every point of light is an exhibit, every star a document from a different chapter of history. Now look deeper. The Pleiades, that beautiful little cluster of stars also in Taurus, sometimes called the Seven Sisters, they are about 440 light-years away. The light you see from the Pleiades tonight left those stars around the year 1585. Shakespeare was alive. Galileo was a young man. Nobody on Earth had yet looked through a telescope at the night sky. And now, the big one. On a very clear night, from a dark location, you can see the Andromeda Galaxy with your naked eye. It appears as a faint, elongated smudge, barely distinguishable from the background glow of the sky. The light from Andromeda that is entering your eye right now left that galaxy approximately 2.537 million years ago. 2,537,000 years ago. At that time, there were no modern humans. Homo sapiens had not yet evolved. The dominant hominid walking the earth was Australopithecus, our distant ancestor. They were bipedal. They used simple stone tools. Their brains were less than half the volume of yours. The light that is landing on your retina at this moment was already in transit when our ancestors were barely recognizable as proto-human. That light has been traveling since before your species existed. It crossed 2.537 million light-years of space, through clouds of gas and dust, past countless other galaxies, threading through the void at 186,000 miles per second, and it ended its journey tonight, in your eye. In your eye, in this moment. Let that sink in. Now consider that Andromeda contains approximately 1 trillion stars, 1,000 billion suns. In 2.537 million years, many of those stars have died. Many new ones have been born. Solar systems have formed and perhaps collapsed. Who knows what has happened in that galaxy in the time since that light left? We have no idea. We cannot know. The information about what Andromeda looks like today, right now, as it actually exists at this moment, will not reach us for another 2.537 million years. We are receiving a message written before humanity was born, describing a place that has since changed beyond recognition. Now go even deeper. The Hubble Space Telescope and more recently the James Webb Space Telescope have done something remarkable. They have pointed at completely empty patches of sky, regions where nothing was visible, and they have simply waited, exposing their sensors for hours, days, accumulating every photon that arrived. And every single time, without exception, what they found was not emptiness. In every dark patch of sky, hiding beyond the threshold of our eyes, are thousands and thousands and thousands of galaxies. In the famous Hubble Ultra Deep Field image, a patch of sky about 1/13 millionth of the total sky, roughly the area covered by a grain of sand held at arm's length, there are approximately 10,000 galaxies. 10,000 galaxies, each containing hundreds of billions of stars, in a patch of sky you could hide behind a grain of sand. The most distant objects in the deepest images are over 13 billion light-years away. We are seeing them as they were just a few 100 million years after the Big Bang. Baby galaxies, still forming, violent and bright, and nothing like the calm, structured galaxies we see today. What are they now? We have absolutely no idea. We are looking at infants and trying to guess what they grew into. We will not know for billions of years. The night sky is not a view, it is an archive, a fossil record, a collection of dispatches from times so distant they make human history look like a single heartbeat. Now, I want to flip this completely around, because everything we have talked about so far is about us looking outward and seeing the past. But what about the reverse? What does the universe see when it looks at us? The light leaving Earth right now, at this moment, is radiating outward in every direction at 186,000 miles per second. Light bouncing off our oceans and our mountains and our cities. Radio waves from our television broadcasts and our radar systems and our cell phone networks. Infrared heat from our buildings and our bodies. All of it spreading out into the cosmos. And every single bit of that information is delayed. By the time it reaches anything, it is old. The light arriving right now at a star 100 light-years away left Earth in 1926, the Roaring Twenties, before World War II, before television, before atomic weapons, before the computer, before the internet, before everything that defines the modern world. Any civilization at that distance, sophisticated enough to detect the faint light signature of our planet, would see Earth as it was a century ago. They would see a planet with a thin film of industrial pollution just beginning to accumulate in the atmosphere. They might detect the first crude radio waves, very faint, barely distinguishable from noise. They would have no idea that just 100 years later, this planet would be covered in electric light bright enough to see from space, wrapped in a dense fog of electromagnetic signals, racing toward transformation at every level. Go further. The light reaching a star 1,000 light-years away right now left Earth in the year 1025, when the Vikings were raiding the coasts of Europe, before the Norman conquest of England, before the Crusades began, before Gothic architecture, before the printing press, before the Renaissance, before every scientific and cultural revolution that defines the modern world. A civilization 1,000 light-years away, looking at Earth tonight, is watching the medieval period. They do not know we exist, not modern us, not industrial, technological, digital us. They are watching a planet with scattered human settlements, no electromagnetic emissions worth detecting, nothing to suggest that this small blue world is any different from millions of other small rocky planets orbiting unremarkable stars. Now push it to the extreme. A civilization 65 million light-years away is looking at Earth right now. The light they are receiving left our planet 65 million years ago. 65 million years ago, there were no humans. There were no mammals of any significance. The dominant creatures on Earth were the dinosaurs in the final years of their 165 million-year reign, just before the asteroid impact that would end almost everything. They are watching the age of dinosaurs, live, in real time from their perspective. They do not know we exist. They cannot know. The light that will eventually tell them about human civilization is still on its way. It has been traveling for 65 million years, and it still has hundreds of thousands of light years to go before it reaches them. We are, to them, an undreamed-of future. And now consider the possibility that we look back at them, that we observe a galaxy 65 million light-years away and it appears to have planets, and some of those planets might have life, and we wonder about them. We are looking at their distant past. They are looking at our distant past. Two civilizations separated by 65 million light-years looking at each other across time, neither one seeing the other as it actually is, each one looking at a ghost. This is not a metaphor. This is precisely, literally, what would be happening if both civilizations existed and both were looking. Now, think about something else. Something that I think has genuinely disturbing implications for how we think about our own future. The light that tells the story of modern human civilization is leaving Earth right now. The light showing our cities from space, the radio waves carrying our broadcasts, the electromagnetic signature of 7 billion people going about their lives. That light will reach nearby stars in decades, stars a few hundred light-years away in centuries, stars across the galaxy in tens of thousands of years, the Andromeda galaxy in 2.5 million years. It will keep going after that, long after the sun has exhausted its fuel and expanded into a red giant and swallowed the Earth, long after every trace of human biology has dissolved back into the atoms it came from, long after every building, every book, every artifact of our civilization has been erased by geology and time. The light will keep going. The light of us, of this civilization, of this peculiar and brief and remarkable species, will travel through the universe for billions of years after we are gone, carrying our story to corners of the cosmos that do not yet know we existed. We will be dead, but our light will not be. And somewhere, far away, long after everything we know has ended, something may receive that light, may decode it, may look at the image of a glowing, city-covered planet and wonder who was there. What a strange kind of immortality. Part 5. The Fermi Paradox Reloaded. 36 minutes to 48 minutes. Estimated 12 minutes. All right, now I want to bring in the concept that I think ties all of this together, and I think understanding light delay completely transforms how we approach one of the most famous unsolved problems in science, the Fermi Paradox. Quick version for anyone who hasn't heard of it. The universe is 13.8 billion years old. It contains an estimated 2 trillion galaxies. The Milky Way alone contains somewhere between 200 and 400 billion stars. We now know that most stars have planets. We know that a significant fraction of those planets are in the habitable zone. We know that the basic chemistry of life, carbon, hydrogen, oxygen, nitrogen, water, is not rare. It is one of the most common arrangements of matter in the universe. Given all of that, the expectation when you run the numbers is that intelligent life should be common, maybe not on every planet, but somewhere, many somewheres, many times over, across billions of years of cosmic history. So here is the question that physicist Enrico Fermi supposedly asked over lunch in 1950. Where is everybody? The universe is old. Intelligent life should have had billions of years to develop, expand, communicate, leave traces. And yet when we look at the sky, we hear nothing. We detect no signals. We see no megastructures. We receive no transmissions. We find no evidence whatsoever of any other technological civilization. Why the silence? There are many proposed answers. The Great Filter, the idea that something eliminates almost every civilization before it becomes detectable. The zoo hypothesis, the idea that advanced civilizations are watching us but deliberately not making contact. The idea that intelligent life is simply so rare that we are genuinely alone. The idea that all civilizations destroy themselves before reaching the point of interstellar communication. These are all fascinating. But today, I want to focus on an answer that I think is underappreciated. Maybe the universe is not quiet. Maybe we just cannot hear it yet. Here's the thing. Our radio bubble, the sphere of space into which our detectable radio signals have traveled, is only about 125 light-years in radius. That sounds like a lot until you remember that the Milky Way is 100,000 light-years across. Our signals have reached a tiny, tiny fraction of our own galaxy, and they are weak. By the time they travel even a few hundred light-years, they have diffused to the point of being barely distinguishable from background noise. Any civilization trying to detect us from more than a few hundred light-years away would need extraordinarily sensitive instruments. We have been shouting into a room the size of a continent, and we have been shouting for less than 100 years. We have barely whispered. And we have been listening with serious equipment for maybe 70 years, in a universe that is 13.8 billion years old. Now imagine a civilization that developed radio technology 1 billion years ago. They have been transmitting for 1 billion years. Their signal bubble is 1 billion light-years in radius. It contains millions of galaxies. Those signals are out there, right now, moving through space, some of them headed in our direction. But a signal that left a civilization 1 billion light-years ago, 1 billion years ago, has been traveling for 1 billion years. It is incredibly diffuse by now, spread over an unimaginable volume of space, enormously weakened. We may not have the technology to detect it yet. Or maybe the signal has not reached us yet. Maybe they are only 500 million light-years away and their signal started 500 million years ago. It is still in transit. It will arrive in 500 million years. We will not be here for that. This is the cosmic communication problem. Even if every galaxy in the observable universe contains thousands of civilizations, communicating across intergalactic distances is not like calling someone on the phone. It's more like sending a message in a bottle and throwing it into an ocean that takes millions of years to cross. You throw the bottle, you wait, you die, your children die, their children die, civilizations rise and fall, and then one day, maybe, the bottle arrives. There is something that I think is genuinely haunting about this. Suppose, somewhere out there, a civilization detected our earliest radio signals, our old television broadcasts, our radar pulses, our Cold War communications. Suppose they were paying attention. Suppose they sent a reply immediately. If they are 1,000 light-years away, their reply is currently on its way, moving at the speed of light. It will arrive on Earth in about 900 more years. We sent the question. We will not live to receive the answer. Our great-great-great-great-great-great-great-great-grandchildren might, if human civilization survives that long, if whoever is living on Earth in 900 years is still listening for signals from space. That is what communication across cosmic distances actually looks like. Not a conversation, a relay, a chain of generations, each one passing on the listening post to the next, hoping that someday, some generation gets to be the one that hears back. And if we ever do receive a signal, if some future generation picks up a transmission from another civilization, the civilization that sent it may already be gone. The signal left them perhaps thousands or millions of years ago. What are they now? We cannot know. We are receiving their past, not their present. We might receive a message from a dead civilization, their last words still echoing through space, an unintentional epitaph arriving long after the funeral. Now I want to introduce something that changes the story in a very fundamental way. Something that makes everything we have talked about even more urgent, even more unsettling. The universe is not just vast, it is expanding. And it is not just expanding, it is accelerating. In 1998, two separate teams of astronomers were trying to measure the rate of cosmic expansion. They were using a type of exploding star called a Type 1a supernova as a standard candle, a reference point of known brightness that allows you to calculate distance. Both teams expected to find that the expansion of the universe was slowing down. This was the obvious expectation. Gravity pulls things together. The Big Bang sent everything flying outward, but gravity should be gradually winning, gradually decelerating the expansion, perhaps eventually bringing everything to a halt, perhaps even causing it to reverse. Instead, both teams found something that shocked the entire field of cosmology. The expansion was not slowing down, it was speeding up. Galaxies are not just moving away from us, they are accelerating away from us. The further away they are, the faster they are receding. And that acceleration is getting stronger over time. Something is pushing everything apart. Something is overpowering gravity on the largest scales. Something that permeates all of space. Something that does not dilute as space expands. Something that grows stronger as the universe grows larger. We call it dark energy. And here is what makes dark energy so philosophically staggering. It accounts for approximately 68% of the total energy content of the universe. 68%, more than 2/3 of everything that exists in energetic terms, is this invisible, inexplicable force that we cannot directly detect and cannot explain. Another 27% is dark matter, a different kind of invisible stuff that we can detect through its gravitational effects but have never directly observed. Add those together, 68 plus 27, that is 95%. Everything else, all the ordinary matter, all the atoms, all the stars, all the planets, all the galaxies, all the gas and dust and black holes, and everything visible in the universe, everything that has ever been cataloged or mapped or named, everything humans have ever directly observed or interacted with, everything that makes up you and me and this planet and every star in the night sky adds up to about 5% of what actually exists. 5%. We are made of the rounding error. We are the footnote at the bottom of a universe whose main text is something we cannot even see. And that unseen 95% is not passive, it is active. Dark energy is actively reshaping the fate of the universe. It is the force driving the acceleration. It is the reason that billions of years from now, the sky will be nearly empty. Here's how it works. Every galaxy that is far enough away from us is, right now, being carried away from us by the expansion of space faster than light can cross the gap. Not the galaxy itself moving faster than light, but the space between us growing faster than light can traverse it. The result is that those galaxies can never send us a signal that will reach us. The signal travels at the speed of light, but the destination keeps moving away faster. It never arrives. It chases forever and never catches up. This boundary is called the cosmic event horizon. And because the expansion is accelerating, the event horizon is shrinking. More and more galaxies are passing beyond it every year. The sphere of the universe that we can, in principle, ever receive information from is getting smaller over time, not larger. In approximately 150 billion years, every galaxy beyond our local group, the small cluster of galaxies that the Milky Way belongs to, will have receded beyond the event horizon. They will vanish from our sky. Not because they exploded, not because they died, but because space between us grew too fast for light to cross. Any astronomers alive in 150 billion years, if any exist, will look out into the universe and see essentially nothing, just our local group, a few dozen galaxies adrift in an apparently empty cosmos. They will have no way of knowing that billions of other galaxies exist. The evidence will have literally left their observable universe, not just out of sight, out of reach, permanently, irrevocably beyond any possible contact. We are fortunate beyond measure to be living in the early universe, when the full grandeur of the cosmos is still visible, when we can still look back nearly to the Big Bang and see the structure of reality laid out before us. That window is closing. Every second, irreversibly, a little more of the universe becomes permanently unknowable. The universe is not just vast, it is vanishing. We have been talking mostly about how distance distorts our view of time, how the finite speed of light means we always see the past. But there is another way that time gets distorted in this universe, and it is arguably even stranger. Gravity bends time. This comes from Einstein's general theory of relativity, the same theory that gave us the understanding of the expanding universe. One of its predictions, one that has now been confirmed experimentally many times, is that time does not flow at the same rate everywhere. It flows faster in weak gravity and slower in strong gravity. Here on Earth, this effect is small but real. Clocks on the surface of the Earth actually run very slightly slower than clocks in orbit. The GPS satellites circling above us have to correct for this effect. If they didn't, your GPS navigation would drift by several miles per day. The engineers who designed these systems had to take Einstein's time dilation into account just to make your phone navigation work. But at the extremes, the effect is not small at all. Black holes are regions of spacetime where gravity becomes so intense that nothing, not even light, can escape. At the boundary of a black hole, called the event horizon, the escape velocity exceeds the speed of light. Once you cross that threshold, you are in a region from which no information can ever reach the outside universe. Notice anything familiar about that language? The event horizon of a black hole functions in a very similar way to the cosmic event horizon we talked about earlier. Beyond either one, no signal can reach you. The universe on the other side is permanently inaccessible. But there is more. Near a black hole, time itself slows dramatically. If you were to hover just outside the event horizon of a massive black hole, time for you near the black hole would pass much more slowly than it does for someone far away. An hour for you near the black hole could be thousands or millions of years for someone watching from a distance. This is not science fiction. It is a mathematical consequence of general relativity that has been tested and confirmed. The movie Interstellar depicted this effect, where a few hours on a planet near a black hole corresponded to decades of time passing back on Earth. The movie got the physics approximately right. What this means for our story today is profound. Suppose some civilization billions of years from now is orbiting close to a supermassive black hole. Time passes slowly for them. From their perspective, centuries of their civilization correspond to billions of years in the outside universe. They could, in principle, outlast the death of stars.
They could survive into an era where the rest of the universe has grown cold and dark simply by sheltering near the time-slowing influence of their black hole. But here is the other side of that coin. From the perspective of the outside universe, they are experiencing time in extreme slow motion. What feels like a long civilization to them is barely a flicker to the cosmos. Time in this universe is not a river flowing at the same speed everywhere. It is a landscape with hills and valleys. It flows faster on the high ground, away from gravity, and slower in the depths, near massive objects. And because of the speed of light, the information we receive about events near black holes is also distorted. Light climbing out of a strong gravitational field is redshifted, stretched to longer wavelengths, losing energy. A signal sent from near a black hole event horizon would arrive here enormously delayed and stretched beyond recognition. The universe does not communicate through a simple neutral medium. Space-time itself is the medium, and space-time is warped and curved by everything that exists in it. Every massive object, every star, every planet, every black hole bends both space and time around it. Light does not travel in straight lines through this universe. It follows curves determined by the mass it passes near. It can be bent, delayed, distorted, sometimes even looped around massive objects. We have observed light from distant galaxies bent around closer galaxy clusters, acting like a cosmic lens, magnifying and distorting images from even further away. We call this gravitational lensing, and it is one of the most dramatic demonstrations of how curved space-time actually is. The universe is not a flat, static backdrop with objects moving through it. It is a dynamic, curved, warping fabric, and everything that moves through it, including light, including time itself, is shaped by that curvature. When you look at a distant galaxy through a gravitational lens, you are not just seeing the past, you are seeing a past that has been bent and magnified, and sometimes split into multiple images by the mass it passed near on its way to you. You are receiving information that has been filtered through the gravitational architecture of the universe. Reality, as it reaches you, has always been edited. Let's go back to the silence of the universe, because there is one proposed explanation for the Fermi paradox that I think deserves a lot more attention than it usually gets, and it is, frankly, terrifying. It is called the Great Filter. The idea was first articulated by Robin Hanson in 1998. It goes like this. For the universe to be as quiet as it appears, something must be preventing intelligent civilizations from becoming detectable. Something is filtering out most potential civilizations before they reach the stage of spreading across the galaxy and leaving unmistakable evidence of their existence. That filter could be in our past, or it could be in our future. If the filter is in our past, then we have already passed through it. Something that kills most potential civilizations, we survived. Maybe the formation of life itself is extraordinarily rare. Maybe the development of complex cells was the hard step. Maybe the evolution of multicellular life. Maybe the development of intelligence. Maybe something specific to Earth's history that allowed us to survive where other lineages failed. If the filter is behind us, then the future is open. We made it through the hard part. The silence of the universe is explained by how unlikely life and intelligence are. We are rare. We are the exception. We beat the odds. That would be wonderful news. But if the filter is ahead of us, if something reliably destroys technological civilizations before they can spread and become detectable, then the silence of the universe is a warning. Maybe every technological civilization invents weapons capable of ending itself before it learns to manage them. Maybe every civilization facing an existential threat fails to cooperate in time to survive it.
Maybe the physics of expansion means that any civilization advanced enough to be detectable is also advanced enough to trigger some catastrophic cosmic process that destroys it. Maybe intelligence is not rare. Maybe it is common. Maybe civilizations arise all the time, and maybe something kills them reliably at a certain stage of development, and maybe we are approaching that stage. Here is what makes this genuinely haunting in the context of our topic today. Even if civilizations regularly destroy themselves, their light continues, their radio signals, their electromagnetic emissions from before the end. We could, right now, be receiving the light of civilizations that have already died. We could be detecting the radio echoes of species that destroyed themselves 1,000 years ago, 1,000,000 years ago. The universe could be full of the light of dead civilizations, a vast graveyard of electromagnetic epitaphs, each one a record of something that existed and struggled and burned brightly, and then went dark. And the silence we perceive, the absence of active communication, might not mean the universe is empty. It might mean we are surrounded by ghosts. Living civilizations sending signals, dead civilizations whose signals are still in transit, the universe full of messages from the gone and the perished and the transformed, all of them still traveling, none of them arriving in any form we can recognize or interpret. The cosmic silence might not be emptiness, it might be the specific, particular silence of a graveyard, where there was once noise, and now there is only the lingering echo. I find that thought simultaneously comforting and devastating. Comforting because it means we are not alone in having existed. Devastating because it might mean we are alone in still being here. In December of 2021, humanity launched the most powerful space telescope ever built, the James Webb Space Telescope. The result of decades of engineering, billions of dollars, and the collaboration of thousands of scientists from multiple countries. And what it has shown us in just the few years since it became operational has already begun to upend our understanding of the early universe. The James Webb Telescope can see farther back in time than any instrument before it. It operates primarily in the infrared, detecting light that has been stretched to longer wavelengths by the expansion of the universe over billions of years. The light from the most distant galaxies it observes left their sources when the universe was less than 300 million years old, less than 2% of its current age. We are looking at the universe in its infancy, and what we have found has surprised us in ways we did not fully anticipate. We expected the earliest galaxies to be small, irregular, still forming, not yet settled into the spirals and ellipticals we see in the local universe. Instead, James Webb has found large, well-formed, surprisingly mature galaxies at distances we thought were too early for such structures to exist. Our models of galaxy formation, our carefully constructed simulations of how the early universe behaved, are being challenged. The universe built things faster than we thought it should have. This is not necessarily a crisis, it is science doing what science does. Observations revising models, new data demanding new explanations, the process of understanding getting more refined. But it is a reminder of something important. Even our understanding of the past, the cosmic past that we read from ancient light, is incomplete. The record we are reading is real, but our ability to interpret it is still developing. We are archaeologists working with incomplete tools on a site that is billions of years old and incomprehensibly vast. Every new instrument, every technological advance, every generation of scientists reveals things that the previous generation could not see. And each new discovery tends to make the story more complex, not simpler. The universe, as we understand it now, is already astonishing beyond the capacity of language to adequately convey. The real universe, the full universe, the universe as it actually is rather than as our current instruments and theories describe it, is almost certainly more astonishing still. We are children standing at the edge of an ocean that extends further than we can see, having just gotten our feet wet for the first time, trying to understand what an ocean is. James Webb also gave us something more visceral than data. It gave us images, real color images processed and calibrated of objects so distant and so ancient that they defy easy comprehension. The deep field image that Webb released in its first operational week showed thousands of galaxies in a patch of sky, some of them as they appeared more than 13 billion years ago. The image was beautiful in the way that only genuinely cosmic things can be beautiful, not the artificial beauty of art, though art tries. The raw, staggering beauty of something real and ancient and beyond the scale of human experience. When you look at that image, you are looking through time as much as through space. Every galaxy in it is a different chapter of history, different distances, different ages, different eras of cosmic time, all arrayed together in a single frame. You are looking at billions of years of history in a single photograph. And all of it is the past. Every photon in that image is a relic, a fossil, a dispatch from an era that is over. Let's bring this home, literally. We have talked about dead stars in the abstract, about Betelgeuse possibly already being gone, about distant suns whose fate we cannot know. But there is one star whose fate we can predict with considerable confidence: our sun. The sun is currently about 4.6 billion years old. It is roughly halfway through its main sequence life, the stable phase where it fuses hydrogen into helium in its core, generating the energy that warms our planet and makes life possible. In approximately 5 billion years, the sun will exhaust the hydrogen in its core. At that point, the physics of stellar evolution will take over, and the sun will begin to change. It will expand dramatically. The outer layers will puff outward as the sun transitions into a red giant. It will grow to perhaps 200 times its current diameter, large enough to swallow Mercury, large enough to swallow Venus, and possibly, at its maximum size, large enough to reach or even engulf the current orbit of Earth.
Even if Earth survives being physically swallowed, it will be sterilized long before that. As the sun brightens over the next billion or so years, its increasing luminosity will drive up Earth's surface temperature. The oceans will eventually evaporate, the atmosphere will be stripped away, the surface will become a scorched, rocky desert. Life on Earth, if it still exists, will need to have moved on by then, or it will end. After the red giant phase, the sun will eject its outer layers into space, creating a cloud of glowing gas called a planetary nebula. The core will be left behind as a white dwarf, a dense, Earth-sized remnant that glows not from nuclear fusion, but from the residual heat of its former life. Over trillions of years, that white dwarf will cool, slowly fading from white to yellow to orange to red to infrared to nothing, eventually becoming what astronomers call a black dwarf, a cold, dark cinder drifting through space. No black dwarfs are thought to exist yet. The universe is not old enough. Even the first stars to form, 13 billion years ago, have not yet had time to cool all the way down. But in the unimaginably distant future, the Milky Way will be full of them, dark, cold ghosts of former stars, stellar corpses providing no light and no warmth to any worlds that might still be orbiting them.
This is the fate of our sun. This is the eventual end of the warmth that makes you possible. But here is the thing I want you to hold on to. Long before the sun dies, the light we have already sent into the universe will still be traveling. The light that left Earth in the Jurassic, the light carrying the first television signals, the light that billions of years from now will still be crossing intergalactic space, carrying a record of this civilization, this era, this moment. The sun will die, the earth will be swallowed or scorched, but the light that left this planet will not stop. It will keep going, long past the death of our star, long past the death of everything recognizable. Our light outlives us. It always has. It always will. Let me ask you something personal before we close. Have you ever felt truly alone? Not just physically alone in a room, but cosmically alone. The feeling of being a small, warm, conscious thing in a universe that is enormous and cold and indifferent. I think most people who really sit with the scale of the universe feel this at some point. And I think it is an honest response. It is not weakness, it is clarity. You are looking at something real and responding to what you see. The universe is 93 billion light-years across in terms of what we can observe. It has been running for 13.8 billion years. It contains more stars than grains of sand on every beach on every continent on Earth. And in all of that, you are one person on one planet, in one solar system, in one ordinary galaxy, in one unremarkable corner of the cosmos. The loneliness of that is real. But here is what I want to offer, not as a consolation that erases the loneliness, but as a different kind of truth alongside it. A rock does not feel alone. A star does not feel alone. A galaxy does not feel alone. You do. Because you are aware. Because somewhere in 13.8 billion years of cosmic history, matter organized itself into something that could comprehend the scale that dwarfs it. Something that could look at a photograph of ancient galaxies and feel something. Something that could watch a video about light and time and cosmic death and sit with it and let it matter. That is not nothing. That is arguably the most extraordinary thing that has ever happened in this universe. You are the universe looking at itself, briefly, imperfectly, vulnerably, but looking. The light entering your eyes right now, ancient photons from stars hundreds and thousands of light years away, has been traveling through empty space for centuries or millennia, and it ended its journey in your eye, triggering a cascade of electrochemical signals that became experience. You are where ancient light comes to rest and becomes awareness. That is not a small thing. That may be the most important thing. Let's end where everything ends. The last stars will burn out roughly 100 trillion years from now. After that, no more starlight. Black holes will persist longer, slowly losing mass through a process called Hawking radiation, a quantum effect that causes them to very, very slowly evaporate. The last black hole, a supermassive one, will finish evaporating in perhaps 10 to the power of 106 years, a number so large it has no useful analogy in human experience, a 1 followed by 106 zeros. After that, nothing. A cold, dark, nearly empty universe, expanding forever, growing colder and more diffuse with every passing moment. No heat, no light, no organized structures, just a thin, cooling fog of elementary particles drifting further apart with every passing eon. And the last light, the final photon emitted by the last evaporating black hole, will travel through that cold, dark, empty universe forever. There will be no one to receive it. But it will travel anyway, because that is what light does. It does not need a destination. It does not need a receiver. It moves at 186,000 miles per second forever through the dark. The last record of everything. A single photon carrying the final account of a universe that existed for an incomprehensible span of time, that burned and expanded and cooled and produced, briefly, in one corner of its vastness, something that was aware of it, moving through a universe that is no longer alive to tell its own story. So, where does that leave us? We are alive right now in a universe that is mostly in the past. Every star we see is a memory. Every galaxy is a history lesson. Every photon that lands on our eyes is a relic of something that happened before we were here to notice. And we ourselves are sending our own light outward. Our cities, our signals, our radio broadcasts, the infrared warmth of our bodies, all of it radiating into the cosmos, becoming old light, heading toward places we will never see, arriving at futures we cannot imagine. We are already dead in the sense that the distant universe sees us. We are already the past to anyone far enough away. But the light we make is real. It travels. It persists long after we are gone. And somewhere, somewhen, across the vast and silent dark, something may receive it, may wonder where it came from, may look in our direction and feel the same question we feel when we look up at the night sky. Is anyone out there? And the answer, delayed by millions of years, encoded in ancient light, will arrive at last. Yes, we were here. We looked up. We wondered. And for a brief, remarkable, improbable moment in the history of this universe, the cosmos was aware of itself. And that was enough.